All right, this video could be labeled more fun with logs. So we're going to go through a bunch of problems that you can try yourself, and I strongly suggest that you stop the video and try them and then restart the video and see if you were correct. So let's start with some word problems. You deposit $1,200 in an account that pays 4.5% annual interest compounded continuously. What will the balance be after 5 years? So pause the video and try this. All right, so what you notice in this word problem is the word compounded continuously. So that alerts you to the fact that you should use the PERT equation. The $1,200 is your principal, the amount that you started with. 4.5% is the rate, and the time is 5 years. Plug those in, put this in your calculator, and you should get $1,503. The air pressure P at sea level is about 14.7 psi. As the altitude H in feet above sea level increases, the air pressure decreases. The relationship between the air pressure and the altitude can be modeled by the equation P equals 14.7 E raised to the negative 0.00004 H. The height of Mount Washington is 6,288 feet. What is the air pressure at the peak of Mount Washington? Well, they give you the equation here, so all you have to do is figure out what variable are they asking you to solve for and what variables are they giving you. They say here the height of Mount Washington is 6,288 feet. So that's the H in the equation. And what is the air pressure at the peak of Mount Washington? Well, the air pressure is P. So you can see that if you just go ahead and plug all of these variables in, put this in your calculator, you should get 11.4 psi. Let's try one more. 200 grams of radium is stored in a container. The amount R in grams of radium present after T years can be modeled by R equals 200 E raised to the negative 0.0043 T. How much radium is present after 1,000 years? Go ahead and pause the video and try this one. All right, so the time is 1,000 years, so you'll plug that in for your variable T, and you're solving for R, you're solving for the amount of radium. Just put this into your calculator, and you should get about 130 grams. All right, we're going to use these law of logs to help us simplify logs based on some given amounts. So this particular log with some base that we don't know of 2 is given to be 0.25. Some log b of 3 is given to be 0.45, and log b of 5 is given to be 0.6. That's given. So what we're going to do is we're going to expand these logs and then evaluate them. So if I have the log base b of 6, remember 6 is not prime, so I can separate that into its prime factors, the log b of 2 plus the log b of 3. Well, I know the log b of 2 is 0.25, and I know the log b of 3 is 0.45, so I can just substitute those values in, add those together, and I could say that the log b of 6 is 0.7. Go ahead and try the log b of 15 and see if you can figure that one out on your own. You'll break down 15 into its prime factors, 3 and 5. We know the log b of 5 is 0.6, the log b of 3 is 0.45. Add those together and you get 1.05. Here are your givens again at the top, log b of 10 and log b of 8. Go ahead and see if you can figure those two out. Log b of 10 can be broken down into its prime factors of log b of 5 plus log b of 2. 5 and 2 is 10, so all you did is expand this. Log b of 5 is given, log b of 2 is given. You just have to add those together for 0.85. The log b of 8 is 0.75. You can write this as the log b of 2 to the third. And remember, this 3 just comes out front, so it's 3 times the log b of 2. And so therefore we know the log b of 2 is 0.25, and we just have to multiply that by 3. Now, we could have gone ahead and set up here at the very beginning, the log b of 8 is the log b of 4 times the log b of 2. But 4 is not prime, so we would have had to then continue to say that's the log b of 2 times the log b of 2. And then you would have gotten to the 0.75 in the end anyways. All right, go ahead and try these two and see how you do. All right, the log b of 18 is 1.15, and the log b of 10 divided by 3 is 0.4. You can break the number 5 down into 2 times the log b of 3 because this would be 3 squared, which is 9, plus log b of 2. 9 times 2 is 18. The log b of 10, here we have division, so we're going to change that to subtraction, but first we have to break down this log b of 10 into 2 and 5. So the log b of 2 plus the log b of 5, and then we're going to subtract the log b of 3. All right, number 7 is a little tricky. See if you can think that one through, and go ahead and try number 8. So number 7, I have 0.95, and number 8, I have negative 0.45. On number 7, you have to change this mixed number 12.5 to 25 over 2. You have to change it to a improper fraction. Once you have that down, then you know that 25 is 5 squared, so then you can break it down to 2 log b of 5 minus the log b of 2 and get your 0.95. Number 8, the log b of 1 over 3, log b of 1 minus the log b of 3. Well, log b of 1 is not actually on our list, but we know that this always is going to equal 0. So anytime you're given a list like this, make sure you also consider that the log b of 1 has to be 0. So then it's just going to be minus 0.45. All right, go ahead and try 9 and 10. All right, number 9 is 0.125, and number 10 is 0.475. Number 9, you'll have to change the square root of 2 to 2 to the 1/2, and then bring the 1/2 out front. So it's 1/2 times the log b of 2, but we know the log b of 2 is 0.25. This one here, we can change it to the log b of 2 plus 1/2 the log b of 3, and then substitute in the values for the log b of 2 and the log b of 3, and you'll get 0.475. All right, here's 2 more. Go ahead and try those. Number 11 is 1.45, and number 12 is 3.05. Number 11, you can break down to the log b of 3 plus the log b of b. Well, what is the log b of b? Well, remember that when these are the same, it's like saying b raised to what power equals b to the 1. So this is going to be just the number 1. So we can, and we know the log b of 3 is 0.45, so this would be 1 plus 0.45 or 1.45. So this is another one of those logs that you're going to want to add to your list. And the log b of 15b squared, you're going to break that up to the log b of 3, log b of 5 plus 2 log b of b. But again, I know the log b of b is 1, so this is really just adding 2. All right, the log 2 of b. Now this one's a little tricky because the ones we are given has the log of b, and this is the log of 2. But if you remember, we had talked about, when we talked about the laws of logs, there was one that I said we're always going to forget, and a way that you could switch these two. So you can actually write this 1 over the log b of 2 because that actually switches the base and the product. And now I know what the log b of 2 is. It's 0.125. But I can't have a fraction and a decimal all in one number. So if you multiply through by 100, you'll get 100 over 25, which you can reduce to 4. Go ahead and try the log 6 of b and see how you do on that one. Again, we can write it as 1 over the log b of 6. This one, 6 is not prime, so I have to write it as the log b of 2 plus the log b of 3, which is 1 over 0.25 plus 0.45, which is 1 over 0.7, multiply through by 10, reduce if you can. But this is already reduced.